one, this comes under covariance. So let us start another function, covariance function. Covariance function. It is represented with C double x or Cxy t comma t plus tau, or it is a Cxy. Okay, t comma t plus tau. Covariance is also two types, autocovariance and cross covariance. This is autocovariance and this is cross covariance. Okay, so autocovariance, how do we write autocovariance? Before that, let us write, I'm going to write the formula for random variables. So covariance of x comma y. What is the formula for this? Basically, it is a expectation of x minus x bar times y minus y bar. Okay. So on solving this, we get r double x minus x bar y bar. This we have seen in the random variables. Okay. Now I'm going to write autocovariance. Okay, for random processes. Excuse me. Yes, sir.
Sir, RXY అయితే కదా sir?
Correct. RXY. This is for random variables. And for random processes. How we have to extend this formula for random processes? We should include time. Okay, so covariance of xt y t plus tau, or this can be also written as cxy. Okay, cxy t comma t plus tau. Okay, yeah, let me write formula for autocovariance. So autocovariance is c double x t comma t plus tau. So what is the formula for covariance? It is r double x of t comma t plus tau minus x bar. X bar is nothing but expectation of xt, and y bar is expectation of y t plus tau. So this way you have to extend the formula of random variables to random process. Next, cross covariance. So it is c xy t comma t plus tau This time we should write cross correlation Rxy t plus tau minus, I think this is x only. This is x because it is auto covariance, right? So expectation of xt, expectation of, now we have to write y t plus tau. Okay. Now coming to properties, there are only two properties. The first property, xt and yt are said to be uncorrelated. Xt and yt are said to be uncorrelated if covariance is 0. If covariance is 0, cxy of tau or cxy of t comma t plus tau is equals to 0. Okay. So how do we prove this? So if xt and yt are independent, what is the cross correlation? Rxy tau or Rxy t comma t plus tau is expectation of xt and expectation of xt plus tau or y t plus tau. Okay. Now let us apply this in a covariance formula cxy tau. What's the formula of this? Rxy tau minus expectation of xt, expectation of y t plus tau. Now let us substitute the above condition. So we get expectation of xt, expectation of y t plus tau minus expectation of xt, expectation of y t plus tau. So these two gets cancelled and it leaves us 0. So covariance 0 represents that xt and yt are uncorrelated. Okay. Next, second one, cxy 0 means tau is 0. The time delay is 0. It is nothing but rxy 0 minus x bar y bar. This is for cross covariance. And c double x auto covariance at 0 equals to cross correlation auto correlation at 0 minus x bar square. Okay. So these are the properties of covariance. So any doubts in this? So let us
x bar y bar ఎట్లా అవుతుంది?
x bar అంటే ఏంటమ్మా?
మీన్
అంతే కదా.
ఎక్స్పెక్టేషన్ ఆఫ్ x అని రాయాలి కదా సార్.
Where మీన్ నే మనం x బార్ తో రిప్రజెంట్ చేస్తాం. Okay, now different notations I'm using. Expectation ne x bar to represent cheyochu.
Okay, sir.
Given autocorrelation function for a stationary process is r double x tau is equals to 25 plus 4 by 1 plus 6 tau square. Find mean square value and variance of xt and variance of xt. So let us write the given autocorrelation function, which is nothing but 25 plus 4 by 1 plus 6 tau square. How do we find the mean square value and variance using autocorrelation function?
Tau is equal to 0 is the mean square value, sir.
Very good. And what about mean? Limit tau tends to infinity of r double x tau gives you the square of the mean. Tau square is equals to tau square. So tau tends to infinity, so the left hand becomes 25 and this is expectation of xt. So what is the mean value? Mean is plus or minus 5. Okay, this way you have to find mean using the properties. Next, mean square value. Mean square value is what? Expectation of x square t. How do you find this? R double x 0 gives you the mean square value. Am I right? Okay, so on substituting tau equal to 0 in the given autocorrelation function, we get the 60 square. So expectation of x square t, nothing but mean square value is 29. And finally, we have to find variance. So variance of xt. So how do we write? It is a mean square value. Mean square value is expectation of x square t minus square of the mean. So mean square value is 29. Square of the mean is 25. So it is 4. Variance is 4. Okay. This way you have to find mean square value and variance of a random process when autocorrelation function is given. Okay. Any doubt in this? The next one is integration of a random process. Integration of a random process. See, there is a block. Okay, this is a system. It performs integration. It's an integrator. Okay. The input for this is a random process xt, and the output for this is a yt, where yt is integral from a to a plus t xt dt, where this t is greater than equal to 0. Okay, a random process is undergoing integration and it gives yt. Then we have to find what is the mean variance of yt. That is our objective. So how do you find mean of this? Mean of yt. How do you find mean of yt? Just we have to apply expectation. Am I right? So expectation is always applied on random process or random variable. So expectation is applied on xt only. This way you have to find mean. Okay. And mean square value. Mean square value of yt. What is this? It is expectation of y square t. If you know the mean and mean square value, we can find out variance. So the expectation of y t equals to integration from minus t to plus t minus mod tau r double x tau d tau. Okay. So based on this, there is a question. The previous question: if xt is a stationary random process, having mean equals to d and autocorrelation function ACF r double x tau is equals to plus 2 times e power minus mod tau. Find mean and variance of a random process y t is equals to integration from 0 to t xt dt. Okay, so mean of xt is given, auto quotation function of xt is given. We should find out mean and variance of yt, which is the integration of xt. Excuse me. Some problem in the software. Yeah. So finding the mean is directly applying expectation on yt. So this is integration from 0 to 2 expectation of xt dt. Already given. What is given? Mean of xt is given. It is 3. So let us substitute that. So integration from 0 to 2, 3 times dt. So it is 3 times t from 0 to 2, which is 3 times 2, 6. So the mean of yt is 6. We have to find variance, but before finding variance, let us find out mean square value of yt. What is the formula for this? Integration from minus t to t, capital T minus mod tau or double x tau d tau. Okay, so we have to know what is t value. So before going to that, let us compare with a integration from a to a plus t, and in the question what is given? Integration from 0 to t. Okay, so on comparing this, we know that a equal to 0 and a plus t equals to 2, so 0 plus t. Okay, so let us find out mean square value. Expectation of y square t is equals to integration from minus 2 to plus 2, 2 minus mod tau r double x tau. It is given as 9 plus 2 times e power minus mod tau d tau. Okay, now we have to split the integration based on mod tau. Okay, this is tau for tau greater than 0, and mod it is minus tau for tau less than 0. Right, so let us split it. Expectation of y square t is equals to integration from minus 2 to 0. So for negative values it is minus tau, so it becomes 2 plus tau, and 9 plus e power tau, 2 times e power tau d tau, and integration from 0 to 2. For tau greater than 0, it is just tau, so 2 minus tau, 9 plus e 2 times e power minus tau d tau. Okay, So I am leaving this integration to you. You have to get 40.542. Now variance of yt. It's a mean square value, expectation of y square t minus square of the mean. So mean square value is 40.542 minus, already we got mean 6, so 6 square. So 40 minus 36, it is a 4.542. So variance. This was the supply question. So any doubts in autocorrelation function, cross correlation function, covariance? Again it is hanging. The next concept is introduction to Gaussian random process. Just introduction is there. Introduction to Gaussian random process. In the previous units, you have learned about Gaussian random variable. That Gaussian random variable as a function of time is a Gaussian random process. Understand? Now, this is t and this is xt, and okay. Now I'm going to consider n number of random variables. Okay, so this is x1, x2, xn. Okay, now these are said to be jointly Gaussian. These random variables are said to be jointly Gaussian if they follows the Gaussian distribution. Okay, xt is a Gaussian random process. In that we are going to obtain n number of random variables. All those are Gaussian random variables only. Okay, so if all random variables random variables x1, x2 up to xn, okay, let me write this way. It's a random process, so let me write xt1. Xt1 is nothing but x1 only, xt2 up to xtn. So these are all the random variables from the random process xt. These are jointly Gaussian. These are jointly Gaussian. Then the process is called Gaussian random process. Or if you simply write a Gaussian random variable as a function of time, it's also correct. Okay. Otherwise, if you draw this plot and from this, if you write this statement, it is very good. Now, the joint density function, I'm writing joint density function. Joint density function. This is f x. So what are the random variables in this? X1, x2 up to xn, and x1 is at t1, x2 is at t2 up to so on, xn is at tn. This is equals to e power minus half of x minus x bar transpose cx inverse times x minus x bar. These are all the matrices. These are all the matrices by root of 2 pi whole power n times mod cx. So where x equals to, it's a column vector. In the column vectors, what are the elements? Variables, random variables, x1, x2, xn. Okay. And what is x bar? It is the expectation of x, right? This is equals to, you have to apply expectation on the elements. So it is expectation of x1, expectation of x2 up to expectation of xn. Okay, we can also write this as x1 bar, x2 bar up to 1 xn bar. Okay, and what about this cx? Covariance. Okay, it's a covariance matrix. Covariance matrix, which is equals to, so covariance between 1 1, covariance between 1 and 2 up to so on, covariance between 1 and n. First random variable, second random variable, and n random variables. Second column, covariance between second and 1, covariance between second and second up to so on, covariance between second and nth random variable. And the last row is covariance between nth random variable and first random variable, covariance between nth random variable and second random variable, up to so on, covariance between n and n random variables. Okay, so if we clearly observe these diagonals are autocovariance. They represents autocovariance, and remaining elements are cross covariances. Okay, and the dimension of this matrix is n cross n. And properties. Properties. If the Gaussian random variables are uncorrelated, they are called statistically independent. Okay. The Gaussian random variables are statistically independent if they are uncorrelated. Second one, I'm going to apply linear transformation on the random variables like a1 x1, a2 x2, just up to so on, an xn. This is called linear transformation. What we call this is linear transformation. Okay, x1 is a Gaussian random variable, x2 is a Gaussian random variable, xn is a Gaussian random variable. After applying linear transformation, we are going to get x. That x is also Gaussian random variable. Okay, so what is the statement? Linear transformation of random variables of Gaussian random variables is also Gaussian. Okay, that is the second. Third one, the conditional density function is also Gaussian. The conditional density function also Gaussian. Based on what we are saying, it's Gaussian by observing the Gaussian density function. What is the Gaussian density function? 1 by root 2 pi sigma square e power x minus m whole square by 2 sigma square. So if the conditional density function is also in that form, we can say that that is also Gaussian. Fourth one, any marginal density function can be obtained. What is the marginal density function? Can anyone tell me?
The density functions obtained from joint density function.
Very good. So any marginal density function can be obtained from how many random variables are here? N number of random variables. Okay. So we are going to get, excuse me, n dimensional density function. N dimensional density function. Okay. Just now I wrote one formula, right? This one, fx, x1, x2, fxn, t1, t2, tn. This formula is n-dimensional density function, or simply it is called as a joint density function where n number of random variables are involved in this. And the fifth one, what are the parameters of a Gaussian random variable? Anyone? What are required for a Gaussian density function? Mean and variance, right? Gaussian random variables are represented with mean and variance. If we don't know mean and variance, we cannot find what is the density function. Similarly, for random processes, the random variables are completely defined using mean, variance, and covariance of xt. Uh, represented by mean variance. Mean and variance are sufficient for a random variable, but whenever many random variables are there, covariance is also required. So this is about Gaussian random process. And the last topic in this unit, introduction to Poisson process. Okay, where we use the Poisson process?
Rarely occurring events.
Rarely occurring events. Accident happens rarely or frequently.
Rarely.
So we can apply to find out accidental distribution. Okay, telephone calls or comes rarely or continuously. In a day, how many times you get called?
5, 6.
Poisson process. It describes a number of times. It describes the number of times that some event has occurred. So that event may be an accident, maybe telephone calls, maybe a customer arriving to a bank. Okay, bus coming to a bus stand, a train arrival, or flight arrivals. Okay, train reach to a station, flights arrival to the airport. So these are all comes under Poisson process. Okay, occurred as a function of time. If you don't write as a function of time, then it is not a random process. Am I right? Some event has occurred, that is a Gaussian random variable, that is a Poisson random variable. That rare event is Poisson random variable. If you include function of time, that Poisson random variable becomes Poisson random process. Okay, so as a function of time, and the event occurs at random times. The event occurs at random times. So for these cases, we use Poisson random process. So for the Poisson random process, the distribution Poisson is a continuous or discrete random variable. Is Poisson continuous random variable or discrete random variable? Anyone? Are you with me? Anyone?
Discrete, sir.
Discrete. So for discrete, we use a probability as a density function. For continuous, we use CDF or PDF as a distribution. So for a Poisson random process, the distribution P n t equals to lambda t power n by n factorial e power minus lambda t. Let us see the properties. First property is the mean of Poisson process is lambda t, and mean square value is equals to lambda t plus lambda t whole square, and variance of Poisson random process is mean square value minus square of the mean. So what do you get? Lambda t only. Next, autocorrelation function R double x t1 and t2. Okay, it is equals to lambda t1 times lambda t2 plus 1. And the third one, sum of two independent Poisson process is also a Poisson process. Sum of two independent Poisson processes is also Poisson. Means the sum also follows the same distribution. Sum or difference, both sum or difference of two Poisson random process also Poisson. The fourth one, the interval between two consecutive occurrences of Poisson process is exponential random variable. The interval between two consecutive occurrences of Poisson process is exponential random variable. So let us write where we apply this application. First application, arrival of customer at a bank. Arrival of customer at a bank, or arrival of bus, the bus station, bus stand, arrival of train, okay, to railway station, arrival of flights. Those are all comes under this first one. Accident in a time interval. In a time interval. If you consider the time interval in the morning 3 to 6 on the highways, okay, so the accidents that follows this Poisson distribution. And the telephone calls also rare. Telephone calls coming to a telephone exchange. The telephone exchange. So this is about Poisson process. So with this, the unit is completed. So any doubts in this unit? Sir, are you there?
Yes, sir.
So tell me the absentees numbers.
Okay, sir. Sir, number 79,
Okay.
85, 86,
Okay.